Okay, so I wanted to do something quite ambitious, which is basically sum up all of coordinate geometry in this video. Basically, what I want to do is look at the gradient of a straight line, the tangent of an angle, and how that relates to the gradient, the midpoint of an interval, the distance between points, and the equation of a straight line. So these are just going to be a very theory-based kind of lesson. But basically, this covers a big chunk of coordinate geometry. So this line here is going to be our famous line. We'll find out all this information about this line, and then we're going to talk about the theory behind it, and we'll cross each one off as we go. So if we talk about the gradient of this line, let's just work it out straight away. What we can do is we can say it's basically the steepness of the line, right? So if you think back to year 9 maths, it's the rise over the run, isn't it? So if we make a triangle out of this, I'll make a polygon, and then we go to here, and then we go across to here, and then back to here. So make a triangle out of it, essentially. What we can do is just remove some of these labels. Go select another. Okay, so basically you work out the gradient, you got to work out the rise over the run. So we can see that in this case here, we start at -2, go up to 6, so it's a rise of 8. Okay, and the run is from 1 to 5, so that's a run of 4. So, we know that the gradient is rise over run. Rise over run, so that's going to be 8/2. Okay, but we need to just be aware that we went in the positive direction, right? So this was +4 because we moved from 1 across this way in the positive direction of the x-axis, and then we went from, -2 up to +6 in the positive, so that's +8. So it's 8 divided by 2. So you just got to be aware of the direction you're traveling as well, because if the line is sloping the other way, we're going to get negative gradients, right? So we just have to be aware of that. So yeah, that's the gradient. If we think about it more generally, what we can say is we can say that the gradient is going to be equal to, well, basically it's just y2 minus y1 over x2 minus x1. Okay, so this is generally the equation for the gradient between any 2 points, and let's see that work in action. So we're going to say, and think about it like this, the y2 minus y1 is just your rise, how far up or down have you gone? And x2 minus x1 is just how far across you've gone. So when you're labeling the points, this one here can be, let's say x2, x2, y2, x1, y1. Okay, so y2 minus y1 is going to be 6, take away -2 over 5, take away 1, which is 8/4, which is 2. Okay, so that's how you find the gradient of a straight line. You just take y2 minus y1, which is the rise, over x2 minus x1. You should got to be careful of negative signs, right? So a 6 take away -2. And when you label them, this is x2 and y2, this is x1, y1. It doesn't matter if this one down here was x2 and y2 and this one was x1, y1, you'll still get the same answer. And I encourage you to have a think about that as well. Okay, let's say that we've done that. So that's the theory behind that. That's probably the key takeaway there. That's the key idea, y2 minus y1 over x2 minus x1. The next thing we probably want to talk about is the tangent of an angle. Okay, so let's have a think what you can actually do, and I encourage you to go onto GeoGebra and try this out. If you want to find an angle, what we can do first is if I put a point at this point here, just on the x-axis, and then if I want to find an angle, and in fact, I'm going to put another point here on my triangle. All right, if I click angle, click that, click that, click that, and it gives me the other angle. I want this angle. quick angle and then go here, here, here. Okay, we get 63 point, oops, get 63.43. So what we can say is that this angle that is made with the positive direction of the x-axis. Okay, so that phrase will get used a fair bit. So the positive direction of the x-axis means the angle created by the line from the positive direction of the x-axis around here. So this angle here happens to be 63.43. Okay, but what you'll notice is something interesting. That line, if we just step this out, think of it as a trigonometry question. Let's think about this length here. Relative to this angle, this would be the opposite side, right? So this has a height of 6 from 0 up to 6. And then, this length here would be the adjacent side, and that has a length of 3. Now, what we can say is that, yeah, if we set up our trig ratio, so tan of theta equals opposite over adjacent. So remember TOA, right? Opposite over adjacent, so 6 over 3. And so if you get on your calculator, and I'll do this in a second, you do the tan inverse of 2, 6 over 3 is just 2. I'm guessing that that's going to be equal to 63.43 degrees. And let me just get the calculator up and I'll show that that works. Okay, so here we go. We just get our calculator, go to our main screen. First thing you want to check is that we're doing everything in degrees for now. So we're going to make sure if we click here, we can change it to gradians and radians. We want it to be in degrees. Okay, then we got to go to trig, because we're talking about trigonometry here. So we want the tan inverse of 2. And lo and behold, it's 63.43. So, sort of just to summarize that part there, if you've got yeah, the tan of the angle is equal to the gradient. So maybe we could summarize that by writing it like this. So tan of the angle, tan of theta equals the gradient, where theta is the angle made with the positive direction of x-axis. Okay, so that's the idea behind that. So that's the tangent of the angle and how that relates to the gradient. So hopefully you can see how that sort of makes sense. You're just looking at a triangle that would be made and then thinking about some sort of trigonometry there. Okay, so we've covered that. Let's do the next part. So the next thing is, yeah, obviously to find the midpoint. And let's again use our example line here to find the midpoint. You can probably have a think where the midpoint would be. It's going to be around here somewhere, right? Like roughly halfway between, 1, -2 and 5, 6. So how can we find that? Well, you can probably just think about it intuitively. If you think it's going to be halfway between, the x coordinates, and then it's going to be halfway between the y coordinates. So let's do that. So let's just work out, yeah, let's just work out sort of what this point on our coordinate on our triangle would be. This would be at 5, -2. Okay, and so basically we just got to find the halfway point between 1 and 5. So 1 plus 5 on 2. And then the halfway point between -2 and 6. And -2 plus 6 over 2. Okay, and so that simplifies to 6 over 2, which is 3, which makes sense. So this point here has an x value of 3. -2 plus 6 is 4. Divided by 2 is 2. So this has a y coordinate 2. And, it's not too bad on the diagram here. It looks about right. That's at the coordinate 3, 2. So you can imagine more generally what we could say is capital M now is equal to find the midpoint, we're just averaging the x coordinates. So, x1 plus x2, whatever the x values of your coordinates are, divided by 2. And then averaging your y coordinates. So y1 plus y2 over 2. And then that formula there will give you your midpoint for any two values. Now remember, sometimes they'll tell you the coordinate of the midpoint, and then you just need to use this formula in reverse. So for example, to say what's the point, so say the x coordinate is at, I won't do an example because it'll get more confusing. But yeah, you just got to be aware that you can use this formula to find points rather than finding the midpoint itself. You can use this formula to find where the original points are on the line if you've been given the midpoint, for example. Okay, let's do the next thing. So we've covered those three. Distance between the points. All right, again, this shouldn't be too bad. The distance between the points is just using Pythagoras. So this is going to be, let's just relabel this. This was the point 5, -2. Okay, the distance between the points. Okay, so we need to know this length here. Essentially, we need to know this length, which, as you can see, is the hypotenuse of a right angle triangle. So we know that c squared equals a squared plus b squared. So we know from Pythagoras, all right, we know this distance is going to be from 1 to 5, which is a distance of 4, and then this was a distance of 8. So c squared equals 4 squared plus 8 squared. So c squared equals 16 plus 84. So c equals 16 plus 84 is 100. So c equals the positive square root of 100, right? Which is 10. So this actually worked out very nicely. So this here has a length of 10. So 4, 8, and 10 must be what we call a Pythagorean triple. So what I mean by that is, and I didn't mean that on purpose actually, which is pretty cool. 4 squared plus 8 squared is 10 squared. Okay, so that's how you find the distance between the points. So if we think about that generally, I encourage you to think about it before I write it down. The distance between the points in terms of, x coordinates, y coordinates is going to be, okay, well, essentially it's just going to be, let's call it d for the distance between the points. You can see that we took the square root at the end. And to get the 4, well, we took x2 minus x1 all squared. x2 minus x1 all squared plus y2 minus y1 all squared. Okay, so that looks like a confusing formula, but it's literally just applying Pythagoras. You're just working out the distance between your x values, and then squaring it, and then adding the distance between your y values, and then squaring it, and then taking the square root of all that. So it's just an application of Pythagoras. So that's the distance between the points. Done. Okay, last one. The equation of a straight line. So we've done all of these. We've done all of this, this, and this. The equation. How can we find the equation? Well, we know that equations have y equals mx plus c. Straight lines have equations y equals mx plus c as their equation. Okay, we know the gradient from before, from this part, was a gradient of 2. So straight away, we can say y equals 2x plus c. Okay, and then we've done a lot of this now, so this should be hopefully reasonably straightforward. We're going to substitute in the y values and the x values. So we're going to do substitute in an x value, y value rather of 6. It doesn't matter which one I pick. I can pick either one. So I'm going to substitute in a y value of 6 equals 2 times 5 plus c. And so what we get is 6 equals 10 plus c. C equals -4. Okay, so our full equation is y equals 2x minus 4. And that's terrible handwriting. Let's redo that. (2x minus 4). That's just as bad handwriting. How good. All right. So yeah, we know the equation is 2x minus 4. We can check that on GeoGebra. So what I can do is just try this out for a second. You can check this too if you like. So if I put in a line y equals 2x minus 4, you can see that it goes through exactly those two coordinates that we were talking about. So that's how you work out the equational line. Now you're probably thinking more generally, how would we work out the equational line? Well, yeah, this is, I suppose what we could say is this. We know that the gradient is equal to y2. Let me make sure I get this right. Yeah, so we know that from before that the gradient is equal to y2 minus y1 over x2 minus x1. Okay, but assuming we know what the gradient is, if we know that the gradient is m, we know m, and let's say we know 1 point, so let's say we know our x1, y1, then we're going to get m equals y2 minus y2 minus y over x2 minus x. If we just rearrange this to get y as the subject, I'm going to multiply both sides by x2 minus x. So I'm going to get m x2 minus x equals y2 minus y. Yeah, so we get something like this, and then if we substitute in the things we know that in this equation, just to show that it works, we're going to get m equals 2, okay, x2. So let's just pick one of the points. Let's pick x being 5 minus x equals y2, or the y2 value is 6 minus y. Okay, now if we rearrange this for y, I'm going to get, so this multiplies in, so you get 10 minus 2x equals 6 minus y. Okay, subtract the 6, I'm going to get minus 2x, subtract the 6 from that side, plus 4 equals negative y. So y equals 2x minus 4, which is what we said earlier. That's the gradient of that. That's the equation of that line. And then so we've done all of it. We've done the equation of a straight line as well. Now, I know that probably seems easy in terms of this is a simple example, and then the questions you get tend to be a little bit harder. But fundamentally, if you understand all of those processes, every question, a lot of the questions in the sort of beginning stages of coordinate geometry are just applications of those 5 concepts. The only thing we maybe didn't talk about, which might be worthwhile talking about, is the equations of straight lines. So if I just clear all this. So if I think about if we think about a few interesting lines, let's just do y equals ax. A is a slider. Y, and let's say y equals a, let's say b multiplied by x. Let's delete this one. Okay. Let's move over Desmos. It's a bit easier for this type of stuff. So yeah, the one thing we didn't talk about is the gradient of sort of special lines. So this is the line y equals ax, but if a is 1, so this is just the line y equals x. If I make a larger, I'm going to get 2, 3, 4, 5. It gets steeper and steeper. Okay. We'll talk more about that in a second. If the gradient, if the a value is 0, then you have a flat line, and the gradient is 0. And if it slopes in the negative direction, it goes like this. So yeah, it's negative if it goes in that direction. Okay, if the line was vertical, I can't even make it vertical on here because it won't go high enough, because it doesn't make sense to be vertical either, because the gradient would be infinitely steep. Imagine it's like, think about it like this. If I'm at a 0 gradient, I'm climbing a mountain, let's say. If it's positive gradient, I sort of have to work uphill. If it's a negative gradient, I'm sort of going downhill. If it's a 0 gradient, I don't have to put in energy. I don't know, I can just walk on flat ground. But if I had to climb a vertical wall, it would be undefined. So a vertical line, so lines like x equals 3, a line's x equals a constant, anything that's vertical is going to have an undefined gradient. Okay, anything that's y equals like a constant, like this, we're going to have a gradient of 0. Okay, so difference between 0 and undefined, and we talk about the gradients here. Okay, that's it. You got to try all the difficult questions that are set for you in this topic. Good luck.